Good afternoon, everyone. My name is Cunjion. I am from Sichuan Normal University, PR of China. My topic is estimating forest canopy density using next-set team data based on sub-compartment objects. Forest canopy density is an important index of differentiating woodland and sparse woodland, and also an important index of forest quality. Its change will affect the spatial variation of the forest stand ecological factors. Remote sensing open a new method for obtaining forest canopy density. Some researchers starts reported that came some bands and derivative data can be used in explaining relationship to canopy density. Also, some researchers reported Sabre's data also can be used to explaining relationship to canopy density. Forest canopy density highly related to red and green band of support, and lowly related to infrared band. This geological issue of model estimating forest canopy density established by using red band and green band. In our China, two projects were carried through. One is primary protection, another project is returning farmland to forest. The forest canopy density investing is used very important in this those two projects. We also have two forest inventory. One is fixed plus forest inventory. This forest inventory was carried through per 5 years. Another forest inventory was carried through per 10 years. So now we have many forest inventory field data, and on the other hand, we also have many landscape team remote sensing data. How to combine the two data to discover some relationship, discover some knowledge. This is my work. Want to combine two data to discover some knowledge here. My study area was located in Sichuan province, Simian County, PR of China. Mountain dominated the study area. Mostly rivers and streams originate here. The climate is subtropical moisture. Forest vegetation and animals are abundant here. Gonga Mountain National Nature Reservation Area and Lizping Provincial Nature Reservoir are located in the area. You can see this is Sichuan province of PR China. This province located at the southwest of China. The study area located in Sichuan province. You can see here. This is Sichuan Basin, and this is Norman Mountain. The large earthquake took place in 2008. Large earthquake took place here, and this is my study area. In this area, the highest mountain near this area, the elevation of the mountain is about 7,000 meters above sea level. The top of the mountain is covered by permanent ice and snow. And you can find panda in this area. You know panda. You also can see the vegetation is very abundant, and some stream originated from this area. I use three data. One data is landsat team. This data was appeared on June 6, 1994. Another data is topographic map on the scale of 1 to 50,000. The third data is forest resource inventory data. This data was obtained by field inventory in 1980. This data includes forest map and some attribute data. This is the landsat team data in study area. And we use the forest inventory data to create forest canopy density GIS database. This is the method to create a GIS database. First is by scanning forest map and the topographic map and the geocoordinate forest map image. Secondly, by digitizing forest map image and get sub-compartment spatial data, and then link and ending the sub-compartment attribute data with sub-compartment spatial data. This attribute data include about 30 factors. One important factor is forest canopy density. So, by creating forest canopy density GIS database, you can see this is the forest canopy density GIS database. You can see the spatial data and the attribute data. Here is the forest canopy density. This polygon forest canopy density is 0.6. Method. Our method included several steps. First is steps data processing, geometrical correction, landsat image, and the topographic map were used here, selecting obvious ground control points. Use these control points and polynomial transformation model to predict the landsat team. And the near-visited neighbor sample algorithm was used. And now we got the geometrically corrected landsat scheme. And then we match the GIS database very well. So can use the two data to discover some knowledge. In order to discover some knowledge, we also need transform landsat data to some vertical data. we use several vegetation indexes such as NDVI, RVI, PVI, SARVI, TSAVI. Their equation as follows. Here is the equation to create several vegetation indexes. We also use principal component analysis to process the dataset scheme and got three principal components. First, the principal components, and the second and the third. This data will be using, and we also use tested table transformation to get three features such as bright leaves, brown leaves, and wet leaves. And we also make some equation to calculate the other derivative data, such as two derivative data. The secondly, obtaining sample data. How to getting sample data? We use dataset team and its derivative data overlay with the GIS database overlay and statistics based on subcomponent. The subcomponent is a unity. And the pixel average and the standard deviation value for each band and for each subcomponent. The other features, average and the standard deviation value for each features and each subcomponent, and add those values to the GIS database. And then selecting samples based on the subcomponents. Here, with inner homogeneity. And now we got sample data about 100 to 1,204 forest subcomponents sample data. This data was used to discover some knowledge. Here is the overlay. You can see the boundary of subcomponent and the dataset team bands and the other features. Here is the value of subcomponent for each band. For example, for team band 1, this is the subcomponent number, okay, and this is the value, mean, max, range, mean, standard deviation, and average. First knowledge is correlation knowledge. You can see we find correlation coefficients for our forest canopy density related to dataset team. From band 1 to band 7, we only find band 7 is sensitive to forest canopy density. You can see here. But the sensitivity is a lot higher. For the derivative feature is MVI tray, and another feature is the third prepensile component. And the other is the team band 7 was divided by band 2. So we have 4 bands or features. We use the 4 bands or features to establish model by using stepwise regression analysis. This was our model. We use 804 forest sample to create the model. We also use 400 samples to assess the accuracy of the model. It was found. This is the equation. It was found. The model was the accuracy of the model is about 68%. So conclusion. From my paper, I got some results. Team band 7 was negative and significant related to forest canopy density. Both the third principal component and this one were negative and significant related to forest canopy density. This vegetation index was positive and significant related to forest canopy density. The other data and other features was not significant related to forest canopy density. The model of estimating the forest canopy density was established here by using team band 7 and the third principal component based on forest subcomponent compartment objects, and its accuracy was 68%. Thank you for your attention.
Thank you. Also, the time is very limited, so let's move on to next presentation. Next presenter is Andrew Bear.